Hello and welcome to today's class. So we are going to look at what we call identity matrix. All right. So if you've ever taken a number times its reciprocal and you've gotten one, we can talk of two times a half. All right. So two is the number and a half is the reciprocal of two. So when you multiply two and a half, you end up getting one. So there's usually a consistent pattern where when you take a number and multiply it by its reciprocal, you get 1. Now, when you take a matrix and you multiply, let's say a matrix A, all right, and you multiply it by its inverse, that is A raised to 1, you will get what we call an identity matrix, which we always denote by capital letter I. All right. So basically, I here is the same as 1 for when you take a number and multiply by its inverse, of course. So therefore it means that if I was to take A, which is the matrix I'm having here, and I was to multiply it by its identity, I'm expecting that I won't get any other matrix. I'll get A because I, which is our identity matrix here, is the same as having 1. All right. So what does an identity matrix really look like? All right. So an identity matrix, if you are talking of, let's say, a matrix of order 2 by 2, we will talk of a situation where we are having 1 in the main diagonal. So all the elements in the main diagonal have to be 1. And so the elements in the other diagonal will be 0. That is if you are talking of a 2 by 2 matrix. And if you are to talk of a 3 by 3 matrix, the same concept will apply. Okay, so usually it is the elements that are in the main diagonal that are 1. Okay, so if you're talking of a 3 by 3 matrix, so we're going to have 1, 1, and 1 in the main diagonal, all the elements in the main diagonal. So any other remaining element within the matrix of this order 3 by 3 will basically be an identity of this particular matrix. And so when you're talking of identity matrix, I want to also maybe remind you that we are talking of square matrices. So it's a matrix, it's an identity matrix of 2 by 2, 3 by 3, 4 by 4, and n by n as we go to infinity, irrespective of what the order may be. All right, so that is what an identity matrix usually looks like. So it is a matrix whose elements in the main diagonal are usually the digit 1, and then any other element remaining, of course it has to be a square matrix, any other element within the matrix is usually 0. All right, so we are going to handle an example where we're going to take a matrix and multiply it by its identity and see what we get. Of course, we expect that when you take a matrix, multiply it by its identity, you are going to get the same matrix, as an identity is the same as 1. Let's go ahead and do an example in that and see what we get. Yes, so we have a situation here where we're supposed to work out the product of multiplying A and I, okay? Matrix A and matrix I right there. And so this is our matrix A. Matrix A is given matrix A is a 2 by 2 matrix with the following elements: 2, 1, 1, 1. And of course, matrix I is an identity matrix. You can see that the elements in the main diagonal are all 1, and all the other elements within the matrix are 0. All right, so that there is an identity matrix of order 2 by 2. All right, so before we multiply matrices, we always want to check on compatibility. So you can see that this here is a matrix of order 2 by 2. All right, multiplying a matrix of order 2 by 2. All right, and so you notice that these numbers here are alike. They are similar. It's 2 and 2, and therefore we can conclusively say that they are compatible. Therefore, we can go ahead and multiply the two matrices. So if we are to multiply the two matrices, we are having 2, 1, 1, 1, and we are multiplying it by its identity, 1, 0, 0, 1, right there. Of course, we already know what our answer should look like. Remember, when you're multiplying a matrix by its identity, we always get the same matrix as our answer, all right? Because an identity is the same as having 1, all right? So it's like a matrix multiplied by 1. So there's really not going to be any change. So we're expecting that our answer here will be the matrix A, because we are just multiplying the matrix by 1. All right, so rows multiplying column, all right, rows multiplying column. So it's going to be 2 times 1, all right, 2 times 1, all right, plus 1 times 0, plus 1 times 0, okay, for the first one. And then for the second column, we're going to have 2 times 0. We're going to have 2 times 0 plus 1 times 1, plus 1 times 1 right there. Awesome. Okay, so second row we are having 1 times 1 right there, 1 times 1 plus 1 times 0 plus 1 times 0 right there. All right, so second row, second column, we are having row 1 multiplying, of course, column 2, row 2 multiplying column 2 there. We are going to have 1 times 0, 1 times 0 plus 1 times 1, all right, 1 times 1 right there. All right, so basically when we multiply these, we are going to get, so 1 times 1, all right, is 2 times 1 is going to be 2, all right, plus 1 plus no, let me just go ahead and do the whole thing so that there's no confusion. So 2 times 1 is going to be 2, plus 1 times 0 will be 0, all right, 2 times 0 here will be 0, plus 1 times 1 will be 1, all right, 1 times 1 will be 1, plus 1 times 0 will be 0, then here we are having 2, actually 1 times 0, yeah, 1 times 0 will be 0, plus 1 times 1 will be 1. All right, so if we multiply, if we add, if we sum these elements here, it's going to be 2 plus 0 giving us 2, and 0 plus 1 giving us 1, and of course 1 plus 0 giving us 1, and 0 plus 1 giving us 1. So basically our final product after multiplying the two matrices is a 2 by 2 matrix with the elements 2, 1, 1, 1, which is the same element, which is the same matrix we had here in A. All right, so I want you to look at this answer, and I want you to look at the matrix A that we had in the previous situation before we had multiplied. So we are actually having 2, 2, 1, 1, 1, 1, 1, 1 right there. So it's the same thing. So anytime you take a matrix and you multiply it by its identity or by an identity, we always expect that you're going to get the same matrix. As identity is just but the same as 1. So another thing that you should also know is that when you multiply a matrix by its inverse, okay, when you multiply a matrix by its inverse, you are always going to get an identity. All right, it's the same as taking 2 times the inverse of 2, which is a half, you're going to get 1. When you take 3 times its inverse, which is a third, you're going to get 1. So I want us to work out an example where we're going to take a matrix and we're going to try multiply it by its inverse and see what answer we get. Is it going to be an identity matrix as we have said? Let us go ahead and work out that example and see what we get. All right, so we are supposed to verify if the matrices that we have below are inverses of each other. So remember, if they are inverse of each other, if these two matrices actually are inverses of each other, then we expect that a product is going to give us an identity. All right, we expect that the product is going to give us an identity. So to verify this, we are going to multiply these two matrices, and see what we get at the end of that process. So we are going to take, of course, all of them they are compatible, as you can already see, 2 by 2. All right, the columns and the rows in the second matrices are actually similar. The number of columns and the number of rows are actually similar. 2 in this situation, 2 in the other situation. So basically it's 2, 1, and 1, 1, multiply by 1, negative 1, all right, negative 1 and 2. All right, good. So we are going to multiply this and see what we get. All right, so it's going to be row multiplying columns. All right, so row 1, column 1, row 1, column 2. All right, so for row 1, column 1, we're going to get 2 times 1, all right, plus 1 times negative 1 times 1 times negative 1. All right, so row 1, column 2, we are going to get 2 times negative 1, 2 times negative 1 plus 1 times 1 times 2 right there. Awesome. So row 2, column 1, row 2, column 2. All right, so row 2, column 1, we are going to get 1 times 1, all right, plus 1 times negative 1, 1 times negative 1. All right, so row 2, column 2, we are going to get 1 times negative 1 plus 1 times 1 times 2 right there. Awesome. So anyways, we try simplify this. So in the process of simplifying it, what do we get? So it's 2 times 1, that's going to give us 2, all right, plus 1 times negative 1 is going to give us negative 1, okay, and then here we have 2 times negative 1, of course, is going to give us negative 2, all right, plus 2 times 1, which is going to be 2, all right, then 1 times 1 is going to be 1, plus 1 times negative 1 is going to give us negative 1 there, all right, so here 1 times negative 1 is going to give us negative 1, plus 1 times 2 is going to give us 2. All right, so when we simplify this, when we add all these elements, we are going to have 2 plus negative 1. That is the same as 2 minus 1. All right, 2 plus negative 1 is going to give us 1. All right, then of course negative 2 plus 2 is going to give us 0. Right here we have 1 plus negative 1, which is the same as 1 minus 1. All right, that's going to give us 0. And here we have negative 1 plus 2, which is actually going to give us 1. So I want you to note that this here is an identity matrix. The elements in the main column are all 1, and the other elements in the other row, in the other positions are 0. So basically, these two are inverses of each other. Also proving a point that when you take a matrix and you multiply it by its inverse, you will always get an identity. Now, this knowledge is very important when we start solving simultaneous linear equations, and that is why we had to do this class just prior to that. So see you in the next class, and have a wonderful day. Thank you.